Hello everyone. Now, root locus plot. How to construct root locus plot? By taking one small example, we can see easily we can understand root locus how to construct. You see here the given example. A unity feedback control system has an open loop transfer function g of s is equal to k over s into s square plus 4s plus 30. Sketch the root locus. Here, objective is only sketch the root locus. Now, first step is already it is always root locus. It is symmetrical about an axis, that is real axis. So at the end also you can write that. It is not a problem. Now, coming to the second, we can say step 1. Locate the poles and zeros. First, find the poles and zeros for the given transfer function. From that, you need to locate in the S-plane. So, in the given transfer function, so this is the transfer function. Numerator always gives the zeros and denominator gives the poles. Similar way, here you can find the poles of the open loop transfer function are nothing but roots of the equation, characteristic equation. So here we'll get three roots: s equal to 0, s equal to minus 2 plus or minus j3. Total 3 poles we have. There are no zeros in this. N equal to 3, m equal to 0. And second one, to find the root locus on real axis, whether root locus is on real axis or not. Here we have only one real axis pole. Remaining two poles are complex conjugate pairs. So here we need to see here. You have to take here negative real axis. In this negative real axis, you take any test point on negative real axis to see right of this point how many poles or zeros are there. Sum of the poles and zeros to the right of that particular test point. If it is odd number, it is a part of real axis, root locus on the real axis. Otherwise, it's not. That means here, if you are choose any test point on the negative real axis, then to the right of this particular point, total number of poles and zeros is 1. It is an odd number. So that means entire negative real axis. So it will be part of root locus. It is showing with the bold line. Okay. Then to find the angle of asymptotes and centroid. Centroid is nothing but asymptotic lines meeting point. In the given transfer function, we have 3 poles. Number of root locus branches are nothing but 3 poles. 3 only. 3 minus 0. So no finite 0. We don't have any zeros in the given transfer function. All the 3 root locus branches ends at zeros is infinity. So number of asymptotes required are 3 only. So asymptote angles, by using this formula we can find plus or minus 180 degrees into 2q plus 1 by n minus m, where k equal to 0, 1 and so on, n minus m minus 1. Okay, so if you are substituting k equal to 0, you will get plus or minus 60, 1, 2. Similarly, you can find the angles. So these angles you have to represent at the point. It is called asymptotic lines meeting point. It is nothing but centroid. Centroid we can find by using this formula, sum of the poles minus sum of the zeros by n minus m. So you got minus 1.33. And this is the centroid. At this point only we can draw the dotted lines of asymptotic lines with the angles. And if you observe this one, plus or minus 60, remaining plus or minus 180, again plus or minus 3. These are repetitive angles only. To find the breakaway or break-in points. In the given transfer function, open loop transfer function is given. we can find the closed loop transfer function. From that we can find the characteristic equation, that is denominator polynomial, it is equal to 0, it is a characteristic equation. So from this k equal to s into s square plus 4s plus 13, this is the expression of k. So find by using the dk by ds and equate to 0, you can find the roots here. So dk by ds differentiate with respect to s and equate to 0, we got two roots here, s values minus 1.33 plus j 1.6, another minus 1.33 minus j 1.6. Here, whether these breakaway or break-in points exist, we need to find these roots. It may be, may not be. So you have to substitute these values in the expression of k. If k is getting positive and real values, then it is a breakaway or break-in point. So after substituting, we got both the values or not positive values. So root locus has neither breakaway or nor break-in points. Angle of departure. To find the angle of departure, because in the transfer function we have complex pole. So that is one pole at minus 2 plus j3, another pole minus 2 minus j3. So here you can find the angle of departure at P2 or you can find at P3. First we are taking, this is the reference point at P2. Angle of departure from the complex pole at P2, it is 180 minus sum of the remaining poles, that is pole angles. You can say here theta 1 and theta 2. We don't have other zeros, that's why we are not mentioning here. So we need to find theta 1 and theta 2 from this figure. So theta 1 we can find 180 minus tan inverse 3 by 2. We can find theta 1 and theta 2 it is only 90 degrees. Substitute these values in this expression, we will get the value angle of departure from the complex pole at P2. Similar way, without finding angle of departure at P3 we can find, because just it is a image only. So angle of departure at P3 is plus 33.7 degrees. So this angle of departure at complex pole you can mark by using the protractor. To find the crossing point on imaginary axis, I'll have two methods. Here I am taking only one method, that is the substitution method. So this is the characteristic equation. Substitute s equal to j omega in this expression. Separate imaginary and real parts and equate to 0. You will get here omega, and substitute this value in this expression, you will get k. So the imaginary axis crossing point is plus or minus j 3.6 and the corresponding gain k value is 52. So this is the limiting value of gain for the stability. If it is crossing this value, system is unstable. And root locus, already we discussed about symmetrical about the real axis. By taking all this, we can sketch the root locus in simple graph paper. That is now I am showing here. This is the real axis and this is the imaginary axis. So these three poles, one pole is at origin, another two complex conjugate plates. This is the centroid. From this we got the asymptotic angles, and from the imaginary axis crossing point we found that is j 3.6 minus j 3.6. These are the imaginary axis crossing points, and these are the angles. Angle of departure minus 33.7 at particular P2. If it is at P3 plus 33.37, from the reference you can take here using protractor, and it starts at P3 and it should passes through the value of that is j point 3 point minus j 3.6. Similar way, if you are taking this one minus 33.7 by using protractor, we can take that angle and it it should be passing through the imaginary axis crossing point. At this crossing point, the corresponding gain is 52. If it is crossing that, so system is unstable. So this is the complete root locus plot. Thank you one and all.